And let us begin. So the first thing is, this is the last week of classes. So remember, if you want to turn something in late, get it in by Friday at midnight, 11:59. And yeah, it's just the review, and then it will be the final. Don't forget about the day that's going to happen. Let's just remind ourselves. It'll be this time, but it's not Monday. It's Wednesday of finals week. So don't come here on Monday. There is no class. It's just finals week. So our final is Wednesday at 4. Meet in this room. Okay, so that will be that. I think that's all that I wanted to say. So let's continue with our review. We were talking about Python. We went through loops and functions. I'm allergic to the world right now. We talked about loops and conditionals, sorry, and now it's time for functions. So that's the last little piece of my little cheat sheet here. So a function is just a little piece of code that you can have rerun multiple times, as much as you would like it to rerun. It's just a nice place to do that. And you can have it change ever so slightly its operations by giving it different parameters. So those are the things that you can define the function with. But to make a function in Python, you say def, say its name, comma separate between parentheses its parameters, put a little colon, and then indent, and the body is what gets run when you pass arguments for each parameter. And don't forget about returning stuff. If you give something back, you have to return it. And then to use that function, that beautiful function that you just made, you call it. So you say its name, and then you put between parentheses, just like you did when you defined it, you put arguments to match every parameter, and they would be sent to those parameters. And so what happens is it goes and it runs the code, runs the body of the code with the parameters set to the arguments. With param1 set to arg1 and param2 set to arg2, all that stuff. That's how it works. And then if your function gives something back, you should save it or use it. Maybe you can assign it to a variable. So that's functions in a nutshell, and let's have some examples of that. So a cool example, I think, is an encryption function. So remember the simple encryption idea? It was called the Caesar cipher or ROT13. Caesar cipher. It's just shift every letter in the thing you're trying to encrypt by 13, rotate it 13 in the alphabet. And that means A becomes N, B becomes O, and it also wraps around. So like N becomes A, that's 13 later. It wraps around to the end of the alphabet and starts over again. So that's how that works. And if you were going to encrypt hello, for example, the H would become a U, the E would become an R, all that fun stuff. LL, and then O becomes a B. 13 letters later, wrapping around as necessary. And yeah, that is the encrypted form of hello. And then the beautiful thing about the Caesar cipher is that there are 26 characters in the alphabet. 13 is half of that. So if you just run the Caesar cipher again on your encrypted thing, it will give you hello back. And so that's, I guess, how back in the day when the Romans were fighting, they passed secret messages. So it's very easy to break the cipher. It's a good example, I think. So we're going to make a function, I guess 2 total, but our goal is to make a function that takes some text as a string, like it takes hello, and it returns a encrypted string. Encrypted string. Something along those lines. And so it'll return back urib. And that is what you could send to the, I don't know, the general on the front lines or something. So that's how that works. And so let's make that. Let's make some functions to deal with the Caesar cipher. And the easiest way, well, let's get some scaffolding started. Let's figure out how we want to use it, and then we'll go from there. That will work. So I will make a new file, and I will put it in our folder for today, which is lecture 31, and I'll call it rot13.py. And so here's how I want to use my little functions. Let's see here. I have some like text that I would like to encrypt. So let's get that from the user. Like input, please enter a string to encrypt. And let's just pretend that we're only ever going to encrypt capital letters. So please, user, type a word in all caps. All caps. So we'll do that. And then we have the string that we want the user, that the user wants us to encrypt in the text variable. So there it is. And then we would like to give that to our encryption function, rot13 function to give back its encrypted form. So we'll have like a rot13 function, and we'll give it the text, and then that's in its encrypted form, and we'll print it. That's the goal. And so that's how I would like to use my function. It is easy to think about, or it's easier to break down the process of this encryption into encrypt an entire string and then just encrypt a single character at a time. Because really what we have to do is encrypt the H, encrypt the E. So it would be nice to also have a function to encrypt a single character, and we'll use that to encrypt the whole thing. So we'll have like a rot13 string function, and then that will call a rot13 char function, character function, whatever. So that's our goal. So here's how I want to like implement the rot13 string function. It'll take my text that I would like to encrypt, and I would like to build up an encrypted form of that string. So encrypted string. We'll start it empty, and we're eventually going to like fill it up, and then that will be what we return. Return the encrypted string. Right? That's the goal. So if I have hello, for example, in text, I would like to go through every character and like encrypt the H, encrypt the E, the L, the L, the O. An easy way to go through every character is to use a loop. So let's see here. What could I do? I could use a for loop. I could be like for C in text. That would totally work. But let's get some examples of using a while loop to iterate through something, and we'll use indices, because that's helpful. So let's see here. Or no, let's use indices on the next one. I think this is fine. So what we want to do is go through every character in text and encrypt it. Let's use a for loop. Why not? For every character C in text, what we want to do to it is encrypt that single character C. So we'll have like a rot13 character function. We'll call it on C, and that we'll assume that's going to give us back, once we implement it, the encrypted form of that character. Like it sends the H to the U, the E to the R, all that stuff. So that's a good idea, I think. And then we'll save that. Encrypted character, be that. What we get back from our rot13 char function. And then we'd like to build up this encrypted string. We have a new character now. Maybe we have the U or we have the R. We want to add it to the end of the string that we're building up. So that's the last piece. So encrypted string equals whatever it is right now. I just have a new character to put at the end of it. Plus, you can add a single character with the plus operation, plus this new encrypted character. And so at the start, encrypted string is empty, then we add the U, then we add the R, the Y, the B every time we do this. Okay? Does that make sense how the string function is going to work? The last piece of the puzzle is to make this character version of the function, to encrypt a single character at a time. And the best way that I could think about it, without having to teach you fancier Python stuff, is to make two lists of characters. Two lists of characters, and I guess a string is technically a list of characters. So let's make two strings, one to hold all the characters in the alphabet in normal order. Like this will be a string that holds A, then B, then C, then D, then E, blah, 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 then F. And so a big long string with all the characters in alphabetical order. And then, here's what we'll do. We'll make another string called encrypted characters that holds in the same spot, the same slot, the corresponding encrypted character for that particular character in chars up above. So what does A encrypt to be? It becomes N. So that's what we're going to put in that spot in encrypted chars. That's how we'll do that. And this will be N, O, P, Q, R. It is in order. S, T, dot, dot, dot. And it'll just go through and encrypt every character like that. And so the way that we can encrypt hello now is like, or we're given like the E to encrypt. We will go and look it up. We'll go look it up in chars, figure out where it is. Like, all right, this is index 0, 1, 2, 3, 4, 5. It was index 4. Go to that same index in encrypted chars, and that's your encrypted character. That's how we can do it. So it's searching through a string, figuring out an index, and going to that index in a different string. That is, with our knowledge, I think the easiest way to do that. So let's make that function. Encrypt a single character. And so it takes a C, and like here are all the characters in the alphabet. Give me a second while I just type them in order. G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And then we have encrypted characters, which are all those in order, starting with the encrypted version. So A encrypts to be N, apparently. So this is N, O, P, Q, and it goes in order. R, S, T, U, V, W, X, Y, Z, and then A, B, C, D, E, F, G, H, I, J, K, L, M. And I believe, yeah, that worked out. I didn't miss anybody. Cool. And so those are the two strings that we use. So we got a C, maybe it was H. We look it up in characters, and then we go to the same spot in encrypted characters. That's the encrypted version. That's what we want. So find the index of C in normal characters, and then go there. Go to that index. Same index in encrypted chars to get out that particular character that corresponds to it, the encrypted version. Alright, so that's going to be our strategy. And so I need to figure out an index. I don't know where this character C is. It could be A, it could be Z. So start I at 0, and we'll have to search through every index starting at 0 all the way to the end. So what is the index of the character that we find? We'll save it in this index of char variable. We don't have an index for it yet, so let's start off at -1, something that doesn't exist. And then we'll keep on iterating. While I is a valid index into the character string, while it is a particular index that exists, so while I is less than len of characters, because it goes from 0 to the length -1, that's the last index. If we find at chars of I, that particular character is equal to the C I'm looking for, I'm trying to encrypt, then that is the index of the character. Equals I. You can save it away, and because we found the character, technically you can break out of the loop right now, but that's extra work. I'm trying to not confuse you as much as possible. And so if you didn't find it, you want to look at the next index, so I equals I plus 1, to get ready to look at index 1, index 2, until you find maybe the H, and save that index that you found. So then if you go to that same place in encrypted chars, go to that index, that is your encrypted version of that original character C. Return that. That will do your encryption. And so, with these two functions combined, I believe we have what we want. And I forgot an underscore. And let's see if it works. Enter a string to encrypt all caps. Let's do hello. Yay, we get it. So it's building up a character at a time, the right string. So C gets to be H the first time. It goes and it encrypts that character by finding the corresponding index, and it chooses U. It adds that to the end of the encrypted string, which is right now empty, so it's got the U at the start. And then it goes to the E character. It's got to go and encrypt the E. It goes and it figures out what is that encrypted for. It's like, all right, E goes to R. Returns that. Finds that index. Returns R and adds that to the end of the string, so now it's UR. And then it just keeps on adding to the end, just like that. So that is encryption in a nutshell. It's a nice example of functions, I think. Any questions about this one? Alright, so that's functions. One thing we should definitely talk about is the turtle module. So let's see. I have a few examples of that. What do I want to do? So I guess before turtle, let's do random, because making random numbers does cool stuff. That's important. So the random library, you can look it up. You're allowed to use all this stuff on the final. So Python random. You want to import that. And the two ones that we used in this class were random dot. Let's see, random dot. We definitely use random dot uniform for something. That was to make a random floating point number, random float with decimals maybe between two values. And then there was also random.randint, and I have no clue where that is on this page. There it is. Randint gets you a random integer between those two values. So that's what we use to do cool stuff. Let's do some more cool stuff here. So my first example will be a turtle program, and it will be a random Etch-a-Sketch. Hopefully we know what an Etch-a-Sketch is. It's definitely something I had as a child. Maybe you did too. It's This thing with the little window and the little knobs. You have these two knobs, like you turn them in some order and it will draw lines, and you shake it if you want to erase. Whee! So that's an Etch-a-Sketch. Hopefully we've seen that before. But let's make a random version of that, because we can just have the turtle draw random lines and turn in random directions. So I'll have the turtle draw a bunch of random lines and turn in random directions. So that sounds like a plan to me. And eventually, right, the turtle's going to run out of room eventually, so let's try and keep him inside and have him stop drawing once he goes too far. So let's make sure the turtle stays within, let's only draw randomly within a 600 by 600 rectangle. So that is, this is his drawing range, 0, 0. It's this kind of thing, 600 by 600, I guess it's a square. So this is like the upper right, that's 300, 300, and this is negative 300, negative 300. There we go. So that's that. And what we'll do is the turtle starts out at 0, 0. We'll just keep on saying, hey turtle, go forward by a random amount, and then turn in a random direction. Like go forward a little bit, randomness, turn in a random direction. It could like turn back on himself. That's totally possible. But maybe he'll turn this way and go forward some more randomly, or maybe he'll turn this way and go forward some more randomly. But he will essentially become an Etch-a-Sketch at that point. And the second he tries to go outside of his spot, that's when we stop him. So that will eventually happen due to randomness, but that's the goal. It will be fun. I'll call this Etch-a-Sketch.py. We'll import turtle, and we'll import random. And I like my turtle to look like a turtle, so turtle.shape. Turtle. And so what I'd like to do is keep on doing this, like repeatedly, forever, while true maybe, forever. Go forward, turtle, by a random amount, and then turn by a random multiple of 90 degrees. So it's always like a line. But you could do some other random multiple. Maybe 45 degrees, it might look cooler. I don't know. So that's what I would like to do with the turtle. Go forward by a random amount, I don't know, turtle.forward by random.rand, and what's the smallest we want to go forward? Maybe like 10 to 50. That's the smallest line you can draw, the biggest line you can draw, turtle. And then go left, maybe turtle.left. You could also say turtle.right, it doesn't matter, because like we're going to give him every option between 0, 90, 180, 360, so they're all there. But some random multiple of 90 degrees between 0 and 360. So 0 and 3, I guess. Those are your options, turtle. You turn left by 90, 180, 0, 270. They're all there. So that, you could also just do right. It's the same thing, same idea. You get both. But that's the goal. And we'd also like the turtle to stop once he tries to go outside of the range, so we're going to try and make sure he stays within. Python turtle. You can ask for the turtle's current position with turtle.pause, but if you just want like the x coordinate, I think you can get that too. There's set x. Position. You do x core and y core to get the x coordinate and y coordinates separately from the turtle. But .pause gives you both. Let's use those. Why not? So while the turtle is between, like his x is between negative 300 and 300, so we don't want him to go outside, right? So the x could be between negative 300 and 300, and the y can be between negative 300 and 300. If it ever goes outside, we want to stop. So while the turtle's within the proper spot, so turtle.xcore gives back something less than or equal to 300, and also bigger than or equal to negative 300. Something nice about Python is that you can like do the math kind of inequalities. Like you can do it like this. You can say negative 300 is less than or equal to turtle.xcore less than or equal to 300, which is pretty nice. So while that's true and it's the same for y is also true. So take that, copy it. So while that's true and It's also true for y. Keep drawing. Otherwise, if he goes outside of this bound, stop him. And this will look cool. Whee, there he goes. Look at him draw. He's just moving all around. He's getting very dizzy. But he's drawing cool pictures. And eventually he'll go outside of the range, and we can make him faster and hurry up about it by doing turtle.speed fastest. Because it is random. We have no clue when he's going to get over there. But it looks like he did it this time. Now he's done. Or maybe he's just so far over there I can't see him. I don't know. Yeah, he stopped. Alright, so that's the idea. Let's make him fast. Let's do it again. Because it's random. It'll look different every time. Look at him draw fancy things. Isn't that cool? It's like an old Windows screensaver. And you can change these multiples by like 45. Then I'll move at weird angles, sometimes straight up or down, sometimes perfect angles. And so cool things happen, and it's all random and cool. You can have it change color if you want to, but randomness is fun, and it leads to nice abstract art like this. Any questions about this example? So that's one cool example. What's another one? One that I want to show you, just a nice idea that involves randomness, is you can approximate pi with a dartboard, apparently, which is a cool idea. So let me try and teach you that. So you can approximate pi by throwing darts, and we'll throw virtual darts with randomness inside of the computer. But you can do it in real life too. With enough darts, you can end up with pi. So here's the trick. Here's how you do that. Here's one way to approximate pi. It is pretty inefficient, but we don't care. It's just a cool idea. So let's say that we have a square. Here's a little square. Or no, let's start with a dartboard. It's a circle. A dartboard is a circle. Radius 1. Pretend that's a perfect circle. So radius 1, and draw a box around that circle. So it's like the frame of the dartboard, I don't know. Just have it perfectly touch the edges of that dartboard. And so how wide and tall is this going to be? Well, this is 2 by 2 now, right? Because the radius is 1, the 2 by 2 square, with a radius 1 circle inscribed inside it. And the trick to approximating pi is, if you threw darts at this square, and you were blindfolded and it was perfectly random, you would sometimes hit the dartboard, the circle, or you'd sometimes hit the edges where the circle isn't. You have those options, right? And because it's random, because you're throwing random darts, sometimes you'll hit it, sometimes you won't. But on average, right, after you throw a million darts, you're going to have a lot of them in the circle and just a few of them outside, right? And if it was random, what's the ratio of things inside the circle to outside the circle? It involves the areas of those things. Right here is the circle, it has some area. Here's the outside parts, it has some area. It's just like, that's smaller, of course. That's the idea. So the ratio of number of darts that hit inside the circle to the number of darts that you threw total is going to end up being the same as the ratio of the area of the circle versus the area of the whole darn thing. That makes sense? Because it's random. It could lie anywhere. Just it's a bigger spot, and that's how it's going to work. So what's the area of this circle? That is pi r squared, so pi times 1 squared, which is just pi. And what's the area of this outer rectangle, if you sometimes miss the circle, the dartboard? The outer square, it's 2 by 2, so it's 2 squared, equals 4. So the ratio of area of the dartboard to area of the whole thing is pi over 4. So that means, on average, the number of darts, if you throw infinite darts, the number of darts randomly that hit inside the circle divided by the number of darts total is going to be, it approaches the ratio of those areas, it's going to approach pi over 4. So that's cool. So if we threw random darts, just counted how many landed inside the circle and how many did we throw total, that will give us pi over 4 if we threw infinite darts. We'll just throw a million or something. Once you have pi over 4, you can just multiply by 4 and you have pi. So that's the secret. That is the trick. It's kind of cool. And let's throw some virtual darts. Anyway, we'll get something close to pi, maybe 2 decimal places. It doesn't converge very fast, but that's a cool idea. Darts.pi. So import random. Let's say that we're going to throw 1,000,000 darts. So total darts, got to keep track of that anyway, is 1,000,000. And we need to keep track of all the darts that landed inside the circle. We have 0 to start. And so we're going to repeat for I in range total darts times. We're going to throw a dart. We're going to simulate throwing a dart. Throw a dart and see if it landed inside the circle. And so pretend that you can only hit somewhere within this square. What do we want then? We want to randomly throw a dart, which means we want a random x and y coordinate within this square. That's what we want. And random.uniform will give you a value with decimal places. So x coordinate of the dart that we just threw, if it was random, is random.uniform. It's just a simulation between -1 and +1. Because that is the lower and upper part of that square. Same for y. It's just another random position. And then see if this xy was within the circle. How do we know if it's within the circle? What does it mean? Like, what's the equation of the circle? Well, it's x squared plus y squared equal to 1 squared. Yeah? Which is just 1. And if it's inside, it's either that or smaller. So if x squared plus y squared is less than or equal to 1, that means our random dart landed within the circle. Okay? So we'll use the equation of that circle for that. And so if x squared, x times x I guess, plus y squared is less than or equal to 1, then it landed within the circle. So darts inside circle equals whatever it was plus 1. We just have a new hit. And then at the end, what do we get? This darts inside circle divided by total darts approximates pi over 4. Print darts inside circle divided by total darts. That will be an approximation of pi over 4. So if we multiply that by 4, we'll have an approximation of pi. Isn't that fun? So our computers are luckily very fast. It will throw 1,000,000 virtual darts very quickly. And what did I spell wrong? Sorry. Total darts, plural. What have I done? There we go. Try that. Look at that. 3.14, and then if you round, it gets 1. So that's pretty good for 1,000,000 darts. Or maybe not good. I don't know. Let's throw 10,000,000 darts. What do we get? This one takes a while. It'll take 10 times the amount of time. But this one's a bit better. 3.1415, if you round up, I guess it's not working very well. But it's okay. I guess you round to 2 decimal places, 3.142. Not bad, 10,000,000 darts. That's approximating pi. That's one way to do it. It's a very inefficient way, though. But it's a cool example of randomness. Any questions about this program? Alright, so we've got some turtle examples, we've got some random examples, I think. Let's have turtle plus functions now, and I think those will be some of my last examples. It's complicated as it gets, so let us draw Target logos, because I am fascinated with Target. When I went to UC Santa Barbara, there was not a Target for 5 years that I was there. Only in my 6th year did they give us a Target, finally. Instead, it was a Kmart that everybody went to. It was the 2nd highest grossing Kmart in the country because nothing else was around. The only higher grossing Kmart was in Hawaii. That's how bad we had it. And so luckily, we got a Target, and I would like to pay tribute to Target now by drawing their logo in a bunch of different ways. So let's draw a square Target logo to get the idea, because we know how to draw squares, we know how to fill them. So let's figure this out. How do we draw a square Target logo? Let's make a draw square function, first of all. That will make it easy. That takes a center, like this will be centered at 0, 0 maybe, but it could go anywhere. And then we'll just draw a bunch of squares. Here's the secret. Center, width, and color. will be how we draw our squares. But notice how if you draw a square of width 200, make it all red, then on top of that, draw a square of width 125. Apparently these numbers work well. Make it all white, then it'll look like that outer square got something cut out of it. You're just drawing a white square on top of a red square. And then you draw another red square on top of the white square. That's smaller. That's how you can do it. So that's going to be how we implement it. But we're going to make a draw square function with these three parameters. It takes a center, takes a width, and takes a color, because those are going to change from white to red, big to small. But the center will remain the same. Call this target square. Display everything I want to display. Let's find out. Let's see. So let me steal some of my Etch-a-Sketch stuff. Import all this. I guess I don't need random, but who cares? I'll keep these things. And then we want to make a draw square function. And like we want to draw a target logo like this. So here's how I want to use my draw square function. That takes a center, a width, and a color. It takes, let's draw a square centered at always 0, 0, with a width of 200 to start, and then that color will be red. It'll be the biggest square. And then inside of that, we want a white square. So again, 0, 0 is a center, 125 is a good inner size for the white square, and we change that parameter. And then finally, we draw one more square. They're all centered at the same spot, but this one's tiny, and it's red again. And that will give us a target. All right, so let's make the draw square function. It takes a center, it takes a width, and it takes a color. So we need to figure out where the center is and like get there, because the center could be anywhere technically. So let's figure that out. Where this is, we're getting this coordinate passed to us in the center variable, and like it's a tuple. It's got two things. It's got center x and center y. So center x is the 0th thing, center y is the 1th thing, I guess. That's how you can think about it. And so we can extract those from the center variable. So center x is go into the center tuple and get the 0th thing out. Center y, similar idea. Now I have the center. And then, how do we know how to draw a square? It was always, I think we started in the upper left, right? So, and then we started like facing right, going down, drawing things like that. That's how we drew our squares. So, all right, if I have this coordinate, I need to get this coordinate. How do I do it? Well, I have the width of this square. This square is supposed to be width 200. So I need to go over by half, go over by 100, and then go up 100. And that will give me my upper left coordinate. So how do I get that from center x and center y? Well, the upper left coordinate is center x, well, the x part at least, is center x here. Go left 100 in the x direction, so minus 100, which generalized is width over 2, right? Because we're going to draw multiple squares here of different widths. Minus width over 2. And then, comma, what's the y coordinate? Well, it's the y coordinate of this one, but go up 100, so plus 100 that time. So center y plus width over 2. And that's your upper left. And then we know how to draw a square. We've made a draw square function with an upper left before. So that works out. And we just do that for everybody. Like this one's 125, this one's 50. And it should all be happy. So let's do that. Alright, I have the center x, y. I need upper left. That is center x minus width over 2, comma, center y plus width over 2. And then we want to go there. So turtle.up to pick them up. Don't draw anything yet. Turtle.go to that spot, UL. And then we want to like draw a square. So we don't know where the turtle's facing right now. We want to make sure he's facing right so that we can go forward, turn right by 90, forward, right by 90, all that stuff. So turtle dot down to be ready to draw, and then turtle.set heading 0. That makes them face right or east. All right, so that's what we want, and then we want to draw a square. So let's draw that square first of all. So it's turtle dot forward. We'll deal with color in a second. Turtle dot forward by the width. So that was 200, right? So that was the upper spot, and then we turn right 90, and then go forward by width again. That's the game we keep playing. Boop, boop, boop. And so once we've done it 4 times, we've drawn all the edges. And what we'd like to do, though, is fill this in. We fill this in with a certain color. The color was passed to us. So that's your fill color. So turtle.fill color. Set it to the color that was given to us. And then to ensure that this square is filled in, you have to mark it with begin fill and end fill. Remember that? So turtle.begin fill. And then once you're done drawing and you've closed it off, you say turtle.end fill. That will give us a draw square function, I believe. So relative to a center with a certain width for that, that square and a color. And so we've called it 3 times. Let's see if we get a target logo. Oh yeah, that looks beautiful. Apparently it's not exact for some weird reason. It's a little jagged, but that's as good as we can do. Maybe if I zoomed in or had a better screen, it would look better. But that is a good enough target logo for me. Any questions about how this code leads to that? So if you think about it very slowly, let's get rid of the fastest part. You just watch it work. It's first drawing the red square, then the white over that, and then the red over that. That's how it's working. But we're reusing the function that we made, which is nice. All right. So that's the square target logo. Let's make the real target logo. Let's generalize what we did. So let's see here. We would like to make a circular target logo, and it will be the same idea. It's just we're going to draw circles a bunch of times with a center, a radius, and things like that. We can think of the width as the diameter, maybe. But yeah, let's do this one. This is the real logo. Let's make it happen. And so again, we're going to get the center. We have to draw it. For drawing circles, though, when you draw a circle, there is a library function. If you haven't seen it before, I think it's just turtle.circle. Let me find it. There it is. So yeah, turtle.circle draws a circle, a whole circle, and or a portion of a circle. But what this function needs, when you call it, you give it a radius of your circle, first of all. But you also, it will draw the circle starting from the bottom. So if we said, hey, turtle, draw a circle from right here where you are, he will draw a circle like this. It's always relative to the bottom. So we need to move the turtle down to here before we start. And then it'll draw the circle with the center that we wanted. That's the secret to the circle function inside the library, at least. So let's do that. This will be the circle version of the program. So let's steal all this code, new program, paste it, and we'll call this turtle, I don't know, improved. So our draw square function is fine. This is drawing a like a circle, or sorry, a square-based target logo. But let's comment these out. And let's use this idea. Instead of this, let's do draw a circle in this way. So we're going to make a draw circle function that functions in the same way. So width will be diameter, I guess, as far as circles are concerned. But if instead of draw square, we just had draw circle, we could draw it in the same way 3 times and get a circular form. Let's do that. So let's add a draw circle function that's going to be very similar to the draw square function. What it needs, though, is we don't want to start in the upper left anymore. We want to start at like the bottom. So we want like a starting point. It's relative to the center, though. So if this was the center that we were given, if this is center x and center y right here, how do we get to the bottom part? Well, this is width over 2, because we're assuming that width is our diameter. This is width over 2, the radius. We want to go down, keep the same x coordinate, but go down in the y coordinate by width over 2. So we want to start here when we draw the circle. So center, that's just how the library wants it. Center X stays the same, but we go down in the Y. Center Y minus the width over 2. And that gets us to the bottom part of that circle. And that is the wrong program. Where did it go? There we go. So keep the same center X, but go down by width over 2 in center Y. And then, let's see, we can go to, let's just go to starting point. That's what we're calling it now. And then, I guess the heading doesn't really matter, but we'll keep it there, that's fine. And then change the color, and then it's not go forward, it's turtle.circle. And you give the radius of the circle you want to draw, and apparently width is our diameter. So what's the radius of the circle then? It's width over 2. Something like that. And this is a draw circle function now. That should be its name. And so it's very similar. And if we call it in the same way, we will get a circular target logo. Beautiful. Any questions about that? Isn't that lovely? Let's see here. So notice how very similar these two target logo programs were. It's like, well, just draw a square 3 times with those values, or draw a circle 3 times with those values, and you have a target logo. We can generalize that further. So instead of like saying draw a square 3 times or draw a circle 3 times, let's make a function called draw a target logo of a certain style with squares or with circles. You see that? We can make a function that takes another function like the draw circle or the draw square functions as parameters. That's the idea. So I would like to, instead of doing things like this, I'd like to make a draw target logo function. That's a generalization of what we've been doing here. So instead of just saying that 3 times, let's just call draw target logo once. What do we need to draw a target logo? We need to know where the center of it is. So we're given that everywhere. These numbers are hard-coded. We can just save those inside the implementation. So are the colors. All we need to know otherwise is, like, what style do you want it? Do you want it as a square, as a circle? Let's pass along the shape drawing function that we want to use. So we'll pass along the function draw square or draw circle into a variable called draw shape. How about that? And so we'll implement this in just a second. But here's how it will work. Like, I would like to draw a target logo centered at, I don't know, 150 using squares, using the draw square function. Isn't that interesting? So it'll call the draw square function to draw that version of the target logo. Or maybe I want to draw a target logo at -150, -150, but as the normal kind, as a circle, using draw circle. I can pass along which shape drawing function I want to use into another function. That's a very powerful concept that is not very common in C++ if you've used that before. It's really, really nice. And so how do I draw an arbitrary target logo? It's just, well, it's this idea. The numbers are right, the colors are right, it's just sometimes I'm drawing circles, sometimes I'm drawing squares. It's this shape function. Call that. Draw whatever shape function we were given. See how that's a generalization of what we've been doing? And now if I want to draw a target logo, I just call it once. And it'll do the right thing with the shape drawing function. So it's passing along draw a square, and that'll draw a square-ish target logo. This one draws circles. So it'll pass along the draw circle function and draw a circular target logo. Isn't that neat? Where in the world? Oh, there it goes. Whee! Oh, I'm sorry. That was not right, because I was hard coding the 0, 0, my bad. We're passing along the center, I should be using the center. Still looks nice though. There it goes. And so it's passing along which shape function we want to use. So now it's calling draw square. That's what's setting to draw shape. And now in this function called the draw target logo, draw shape is draw circle. So it's a generalization of what we had before. Any questions about that? It's a very powerful idea, being able to pass functions to other functions. All right. With that in mind, let's do all the shapes that we know. Let's do a triangular target logo. Why not? We'll have to add a draw triangle function with a center and a width and all that. But here's how this works. Apparently, assuming the width is like this amount, it's like the bottom edge amount. Assuming that is what you call width in a triangle, because it's kind of arbitrary. I guess this is like that's not the same width, right? The base and the height is a little off, but you can have a center to a triangle, and we know how to draw triangles starting from like the bottom left. That's how I taught you, and facing right and like going forward. So how do you, from the center of a triangle, because that's what we're going to have this function use, right? It's always given the center of where we want to draw this triangle. How do you get to the bottom left? Apparently, this is the formula. You go down a little bit, you go down half your width, or sorry, you go down a third of your width. That's how triangles are weird. Equilateral triangles are weird. So go down a third of your width, and then go over half of your width. That's the goal. So that's apparently how you get to the starting point. That's draw triangle. And so let's have that. I guess that's more closely resembles draw square, so let's start with that one. And we'll call it draw triangle. Cool. Center, width, color. I guess, again, we have like a starting point. It's the bottom left, BL, not UL. And go there. It's center X minus width over 2, so that's still fine. And then center X, center Y minus width over 3. It's not obvious that there's a 3 there, but there is. A student from a past semester helped me with that. And so yeah, go there. And so go forward width, and then it's turn right 180 minus 60, because that's how much you need to turn for that triangle. Remember that? So that will be drawn 3 times. So 1, 2, 3. We don't have a fourth side because we're not a square anymore. And that is your triangle, I believe. Let's draw a triangle with a certain center, width, and color. And then, of course, we can draw a target logo with that idea in mind. So draw a target logo using draw triangle as your shape drawing function. And the center of this triangular target logo, we can put that one at 0, 0. There is our wonderful program. Oh shoot, alright, I did something wrong. Let me fix it. Still looks cool, but I think I did something backwards. Let me double check what I've been doing here. Draw a triangle. Let's see, center X, center Y, center X minus, center Y minus, width over 2, width over 3. Go there. Set the heading, fill the fill color. And oh, I'm sorry. Yeah, I turned the wrong way. It wasn't the same way as it was for a square. If we're drawing a triangle, like we're here, we want to turn left by a certain amount, not right. That was my bad. Let me fix that so it's left instead of right. That should draw a normal looking triangle. Right side up at least. Yeah, every time we call it, it's the draw shape function. It's just being called for us. Gets a chance at being draw square, draw circle, and draw triangle. And there we go. Any questions about any of that? So this is a good program to study, I think. It's got a lot going on. All right. If we're happy, I have some pre-made programs that I made for you just for fun that I wanted to show you. Just some cool examples. You learn how have time to get them to you in class. They're just good, in-depth, very long examples of the kind of stuff that you can do once you know a little bit more. So the first example is, I'm sure you've seen this artist, Pete Mondrian, before, and their artwork. It looks beautiful, very abstract, but we can draw something that looks like this with the turtle library and randomness and functions and stuff. And this is a good example of how you break down a problem. So this is how I chose to do this. So I've made a very long program. You don't have to understand it, but let me open it at least. Mondrian.py. It's very long. It's got all these things. Draw a rectangle, draw a line, pick a random color, a bunch of loops. I believe that you could understand it if you thought about it long enough. But here is how I thought about this. How do you draw this fancy artwork? It's really, secretly, a bunch of lines, right? Like here, just think of a bunch of random lines and draw them. Sometimes they're going inside of things. Like this line is here because it's part of this little square, but it exists everywhere because it is down here too. See that? So just draw it through things if you need to, but essentially how you could draw this is pick random lines that are horizontal and vertical, and then pick a couple of them. Like, all right, pick this line and this line, and then this line and this line, and then randomly pick red, and you've suddenly got a square there. You can draw between the lines, essentially. That's how you can do it. So pick 2 random horizontal lines, 2 random vertical lines, draw a square of a random color. That's how you can do this. That's how I broke it down. And so here's the program in a nutshell. Like I set the turtle to draw very thick lines, and I'll draw a bunch of them. And then I'll overwrite a lot of them with filled squares. Pick some horizontal lines and vertical lines, draw them in a weird place. Apparently this canvas was a 3x4 canvas, so let's draw more horizontal lines than vertical lines. That's apparently what's going on here. And yeah, repeatedly pick some horizontal lines, 2 horizontal lines and 2 vertical lines. Those, like if you pick these 2 and these 2, those correspond to the start and end points of a square or of some rectangle. And then pick a random color and fill it in. And then eventually like crop off the edges as well. And that's pretty much, it's just a very, very complicated use of draw rectangle. That's really all. I believe that you could understand this if you thought about it long enough. But yeah, here's a bunch of things. Draw thick lines very quickly, draw a single line, start and end, pick a random color. Here's our drawing canvas. But here I am drawing a bunch of random horizontal lines. I'm picking random places for them, adding to a list of them. Doing the same for vertical lines. And yeah, just keep on, like, draw them all, first of all. And then repeatedly, I guess I asked the user, repeatedly it picks 2 horizontal lines, random.sample gives you 2 things from a list, and 2 random vertical lines. And then it figures out the upper left coordinate of the rectangle defined by them and its width and height, and it's all cool, and it crops everything. But that is how you could do something like this, and it could be fancier. There it is, picking random stuff. And then apparently I am making this at the mercy of the user, so keep pressing enter to pick some random spots for things. So there it is, drawing weird things. You could make this fancier, but eventually it'll look nice, and that's when you could stop the program, like Q to quit. And it's random every time. That's pretty cool. Let's see here. And there it goes. So that's a fun example that you could study. It's just a good use of all the things that we've been talking about. Just randomly drawing things. And that looks cool. It looked cool, and then it got overwritten because it's random every time. But that's one way to draw some nice abstract art. And eventually, either weird things happen or it goes away. There, whatever. And so that's a fun example, and I encourage you to look at it, but that's fun. Another fun example that I wanted to show you, just to show you the power of even the turtle library. It can be fancy. You remember that Joy Division t-shirt that a lot of people wear with this album on it? This style artwork, maybe you've seen it before, all the hipsters wear it. So this artwork we can recreate in the turtle library. I've made a program for that. Because where they got the artwork was from a public place, and we could steal it too. So that is joydivision.py. it's a very cool example, and I'll let it run while I explain it because it takes a while to run on this computer. But you can have the turtle draw it. It's very nice. And there he goes. He's drawing everything. Because apparently this album artwork comes from somebody's, I think it was like an academic paper where it was like a physicist. They were reading a signal coming from a pulsar out in space. It's apparently this particular pulsar, and I don't really understand those things, but it sends off radio signals because of the way it's doing stuff. And here are a bunch of different like periods of that radio signal's oscillation. And it's just like it went down a little bit, then it changed to be even smaller, then it changed to be even smaller, then it went up a little bit. Just save those offsets, like that's what they did for their work. And each of these could be corresponding to a line in the album artwork. Like this is the graph that they made for their paper, and it just was so cool they put it on an album. So it's just, how could you draw this? Just like, all right, start the turtle down here, move him down some more, move him down some more, move him up a little bit, move him up some more, move them down some more. It's just like the relative difference between those readings. And this is a single line, and this is a brand new line. And it's kind of like overwriting the previous one because it's running out of room. But just take these signals, or just the lists of numbers, and move the turtle down a little bit when it goes down, move the turtle up a little bit when it goes up. That's pretty much it. Of course, that's complicated, but it's, again, draw rectangle. This time it's like draw polygon because there's different points and you gotta fill them in with black to overwrite other stuff. But there's just a bunch of functions. And let's see. I think that's it. Yeah, it just draws stuff. And it just goes through that signal, all the readings, and it starts drawing those little fuzzy looking lines. And I believe that you could understand it again if you looked at it long enough. But that's a cool idea. Like you could take this thing and make it again. And let's see here. Where was I? I think it's trying so hard I might have frozen it, but where is there's the file, and there it is. Is it done? No, it's still working. That's why I started early. On your computer, it would probably be done. It's thinking very hard, but it's almost done. So it's just drawing lines, just offsetting things. And it looks exactly like it should, which is wonderful. And you do have the added bonus at the end there, though. Once it finishes, you get a turtle in the bottom right as well. That's cool. And I think it's done now. So that's my last cool example to show you the power that you could use, that you could extract from Python to make cool abstract art and normal looking art. Yeah. So are there any questions about any of that? Probably easier to look at the code and attempt to understand it. But with that, let's see here. I talked about what's going on, when the final is going to happen. Yeah, that brings us to the end of the class. Yay, we made it. So thank you for putting up with me throughout the semester. Hope you had some fun. And this is a GE class. You do not have to be a CSCI major to take it, but the whole point of this class is to, if you like what you saw, especially during the programming sections, we're trying to poison your mind and hopefully get you to switch to becoming a computer science major or something similar, like computer engineering. Who cares? But if you like this stuff, you could do this forever. And I think that is all that I wanted to say. So, yeah, thank you, guys, and I'll see you on the final day. The rest of the time is yours.